Alright, welcome back everyone. Welcome to the third video on EagleCAD. Today we're going to finish off the circuit that we did last video on LED blinking, the LED blinking circuit, and we'll create a PCB layout for it within Eagle, and then cover some simple and required tools within the Eagle PCB layout editor. Alright, so let's jump into it. First thing we need to do is open Eagle. Got it on my toolbar again here. So that opens, and so last video we created this folder called tutorials inside of our Eagles projects folder. So you're going to expand that. It should already expand like it did for me, but if not, go ahead and expand tutorials and into basic schematics and this schematic. Notice we don't have a PCB yet for it. We only have a schematic. Like this one has both a schematic and a PCB. This one we only have a schematic. So we're just going to go ahead and double click on this to open it, and then maximize the window. So here's a circuit we did last video. It looks pretty good. I think this is all we really need to do for this. So we're going to go ahead and create a PCB layout from all of these parts. So it's very easy and Eagle to do this. All you have to do is come up here to this button right here. It says generate/switch to board. And what we're going to do is press this button, left click on it, and it's going to ask you, do you want to create a .brd file from this schematic. So there is no board file associated with the project right now. So do you want to create one? So we're going to say yes, we do. And here it is. This is our PCB layout. So we have a board outline. We have a bunch of parts here. Let me move some of these around so it looks better. Oh, move it in here. Yeah, the light version of Eagle, you can't put parts out here. I'm not exactly sure what the limit to that is. I guess it's all the way there. You can't go any farther than this. But if you place it within this area, you're okay. So these are our 4 resistors, our 2 transistors, 2 capacitors, our 2 LEDs, and our header. Okay, so these aren't placed in an optimal manner. So they're in these yellow lines that run back and forth. These are called from twos in some application, or rat's nest. It's basically a line telling you where 2 pins are connected. So it takes the schematic that we created last and says, well, this pin needs to be connected to this pin. And if there was more pins, they would also be connected. And in Eagle, it doesn't do this optimally. You have to come down here and press this, see if I can find it. Where is it? Is it this? Calculate shortest airwaves. Yeah, there it is. Rat's nest. So it's that button right there, rat's nest. And now recalculate the shortest path to each thing. So as soon as you move something, you should always go ahead and press the rat's nest again and see if anything changes. It makes it a lot easier. So I'm going to draw or bring the schematic over so we can take a look and see how it's best for us to lay this out. Looks like we need the 2 LEDs at the top, so let's do that. Let's put this one here and this one here. And the way I'm moving this is I'm just using the move tool. I'm clicking once on the part, and then it sticks to my cursor, and then I can move it around. When I want to drop it somewhere, I just left click again. And same thing with the previous tutorial in schematics. When you want to rotate something, if you're moving it and you right click, it's rotating. So see how up here in angle you can see the number change every time I right click? So that's how you rotate something without using the rotate tool. It's a little easier if you're already on the move tool just to right click than to go to the rotate tool and rotate. So this resistor needs to go here. Let's put that there. Here's the other 470 ohms. So we'll rotate that and drop that one right there. Alright, and then we need a capacitor. So these 2 need to go, let's go like this and like that. Okay. And then here, this needs to go something like this. And this will go on this side of it, like that. And then here's the transistors, so let's see how well this fits. Let's put it here. And then this one should go on the opposite side, somewhere over okay, so we'll put it right there. That looks pretty good. And then the header. This is the power input for our circuit. So I'm going to drop that. Well, let's put it over here. I like this, just like that. Okay, so now we have all the parts laid out in a sensible fashion. You can put them any way you want. I suggest you do it so that the from twos are as short as possible. See how when I press the rat's nest, it recalculated it? So there is no like here we have a cross between two from twos. That's not good. We don't want that. We want to try to optimize our design or our layout here so there is the least amount of jumps like this. And we could probably do a lot better with this, but we're trying to keep this video a little bit shorter. You can spend your time and try to optimize the layout here as best as you can, but I'm going to leave it like this. Alright, so now what we need to do is I'm going to move this circuit closer to the bottom corner so that we can shrink this board, because we don't need this huge circuit board just for this small circuit. So to move everything at once, like in the previous video, we need to select everything. So we come over here to the group button. So we left click on the group, so we're selected on the group tool, and then we drag over everything that we want to move. Just like that. Like left click and drag and then release, and it'll select everything. And now we're on the move tool, so we don't need to come over here and click on it. All we have to do is right click in the center somewhere around it and press move group, and now everything's selected so we can move it all at once. So I'm going to drag this over as close to the corner here as possible. That looks pretty good. That way the text doesn't come off the board. And then let's move the outline of the board in farther, so it's not so tall. Actually, let me cover one more thing before we move on to that. The grid button. The grid is extremely important here. Actually, let me change the user interface so we can see it. Actually, I think it's in here. Let me see. There we go. So each one of these little dots is a part of the grid, and I think we have it set to 0.1 inches. Oh no, half inch, or sorry, 50 mils, I would say, 0.05 inches. So I'm going to change this to 0.1 inches, and then I'm going to change this to, yeah, that looks okay. I'm going to leave it at that, a quarter of this. Okay, so now when I move something, see it jumps in bigger pieces, like it's stuck to the grid. If you want something smaller, you either go to the grid here and change this number, but you want it to be a constant, you know, like a standard spacing for everything in your circuit. So most of these things are 0.1 inches apart, like these are divisible by that number. So it's good to keep that spacing here. But we also have the alternate grid. So this is an alternate grid for your PCB layout. So when you're moving something, you can use the 0.1 inch grid, the normal grid, or you can press Alt on the keyboard. Hold Alt on the keyboard. You can see how I have more granularity in moving things. That's what that alternate grid is. So it allows you to set the second grid, the alternate grid. So to access that grid, you press and hold the Alt key on your keyboard. So once we have it where we want, we just left click. So again, see how like it's a big jump between these 2 points? It's because it's 0.1 inches per grid point. And if I press and hold on the keyboard, now I'm having 0.025 inches per grid or per point. Alright, so we covered that well. Now let's go ahead and move this over. So what I'm going to do is let me see here. Let's just move it. So we'll go to the move tool, left click somewhere in the center of the top part here, just once, and drag it down until we find a good spot. So that looks good right there. Okay, and the same thing for this one, right in the center, because if you hit in the left corner, see how it grabs the corner? That's what we don't want. We want to grab the whole side so it moves. So we want to left click in the middle of it. So we're going to left click once, drag it over to where we want it, which is there, and that looks pretty good. Okay, so let's hit the rat's nest button again, make sure there's nothing else we need to optimize. Okay, and let's go ahead and see what some of these are. Okay, so that's the power. This is ground, right? Yeah, it's ground. We didn't label that in the PCB. So that's why it just says N number sign 4. But we'll get to that later, so it changes the name. But what we want to do is we want to lay out tracks here. So we want to connect these pins that have the yellow lines connected with a track. So to do that, we have this tool here called Route. So we left click on that, and it gives you a couple options here, a lot of options actually. So what we want is the top layer. So we're going to change it to top. This we don't have to worry about right now. Radius, don't worry about, leave that at 0. The width here, okay, so this is the width of the track. So if I start routing a track here, see the width here, and if I change this number up to like this, see how it gets thicker? That's what that is. It's just the width of the track. Sometimes you want them bigger, sometimes you want them smaller. It depends on what the track is doing and whatnot. Okay, so, and then also via. We won't get to that quite yet. In the drill and the diameter we'll leave to auto. So the only thing we want to change here is the top. Change it to the top layer, and also the width of the track to 0.016. That sounds good. Okay, so you don't have to do it exactly how I'm doing it here. You can route it however you want. So I'm just gonna go around and route these tracks together. So all I'm doing is I'm clicking on left clicking on the yellow line that I want to route, and then I move my mouse around to see how it fits. And just the same as the rotate tool, you can right click and it'll cycle through the different styles of routing. So this is like a 45 or an arc type thing, and here's another arc. There's a 90-degree type things. There's 45. I like using the 45 personally, so I'm gonna go with that. I'm gonna click there and drag down to there. Notice how when you finish a track, it does a beep. It's like bing. You'll get used to that. Also, let me show you this. So if I left click closer to this hole, this pad, it'll start the track from there. If I left click closer to like this one, see how it starts from there instead of from here? So be aware of that also. Like if you do it in the center, you never know which one it's going to be exactly. So if I do it from there, it'll start from there. If I do it from this side, it'll start from that side. Alright, so let's go ahead and finish routing some of these. So I'm going to run this over to here like that. Run this to there. Let's go like this. Will this fit through here? Yes, nice. Okay. Also, when you're routing, you can press the Alt button and it'll give you more granularity in your route. So in that application I needed it because I needed to go through the center here and not get too close to that. So let's go ahead and finish this routing here. What else can we route? How about this one? This one needs to be routed, so I'm going to hit Alt for this as well. Go down here and then right click so it's a nice angle. There we go. Like that. Like there. Okay. Alright, so let's do this. I'm going to see how I have a cross here. We have to be methodical about how we're routing our board. Try to optimize it as best as possible. So what I could do is go straight across from here and do this. But now I'm gonna have to either route this through here and up through here, which is a big loop to get from there to there, or I'd have to go from the bottom layer to the bottom through here. Now luckily this is a through hole board, so that would work just fine. But if you want to keep the board down, or the price down, or you want to make these boards yourself with like the laser paper type method, it would be much easier to have a single layer board. So I'm gonna erase this track and do something a little bit more simple by bringing this up here, so I have this track to connect, so I don't have to run this all the way around here. Alright, so to rip up a track, to delete a track, notice how if you press this, it won't do anything. It says cannot back annotate this operation. Please do this in the schematic. That's because it thinks you want to completely delete this whole thing and not connect those two pins. Like it thinks you want to delete this rat's nest. We don't want to do that. We just want to rip up the track and leave the rat's nest. So to do that, we go to this tool called the rip up. Right next to the net or the route, it's called rip up. And we just left click on all the tracks that we want to rip up. So those are the two tracks that we wanted to rip up. And we're going to hit rat's nest again to make it nice and clean lines between everything. And then we're going to go back to the route, and we're going to route from here. Let's go up like that. Hit the Alt key again so I got a little bit more room. Make this a little bit neater, like that, and then connect those two. Alright, so I think that's everything, right? Is everything routed now? Yeah, that was pretty simple, right? Alright, so we have two LEDs, we have our power. Some of these things are, so let's fix that. Some of these names are overlapping each other. Like, see how this is, the text is overlapping the via? When we manufacture this board, that wouldn't be good because it's gonna give you an error when you do the design rule check, which I think we'll do in the next videos, to design rule checks, or maybe libraries. I'm not completely sure. But to move one of these names or any of these pieces of text, what we need to do is disconnect this piece of text from this. And to do that, you're using this thing called a smash. So you're going to smash this. It's a tool called smash. Let me see if I can find it. There it is, smash, right there. So you're going to left click on the tool, or on the object, sorry, the component, and see how this piece of text and this piece of text got its own origin, or its own relative origin. Now that's its own object. So now we can grab that and move it around. See how it's still associated with this, but we're allowed to move it? That's exactly what we want. So let's put this, I'm going to press the Alt button so I get a little closer. We'll go red like that, and we'll put the LED part, let's put it above the red. That looks pretty good. And then same thing with the green. So what I like to do is go around and do this for everything that's required. So let's do that for this thing. Let's do it for the transistor here. And this transistor is okay, so we don't have to touch that. I think those are the only devices we need to rip or smash, sorry. So now we can go into the move tool again and move this around to optimize the look of the silk screen. So the layer that these things are on is the T values layer. So this is where all the values are stored of each component. If I clicked on the name one, it would be on T names, top names. That's what that means. So there's T place, top place, bottom place, and so on. We'll do another video strictly on layers as well, so you get used to that. We really need to get used to layers as well. There's so many layers in Eagle, and they all do their own thing. They all have their own reason for using. So let's go ahead and fix this transistor. Move this around like that. That looks pretty good. And I think that's it. If you manufactured this board right now, it would work. All you'd have to do is put all the components down and solder them in, apply power to here, and you're good to go. Now, the one thing that's not good about this circuit is how do you know which pin is plus and which pin is minus? You wouldn't. You would have to like look at the circuit and decide, well, this is on the emitter of the transistor, so that must be ground, and this must be plus because it's going up to the positive pin of the LEDs. But what if you weren't aware of that? So let's put a piece of text here so that we know which one's plus and which one's minus. So first thing I'm going to do is smash this so I can move this component over. And you right click to rotate again. And we'll move that up there so it's kind of out of the way of where we're going to put the text. And we'll grab the text tool and we'll do a plus. And don't worry about the color right now, we'll fix that later. And I'm going to place two of them right next to each other on the opposite sides right here. Now I'm going to go to info. I'm going to press info on this one and I'm going to change this to a minus. See how I did that? Alright, so now let's press info on this one again. We'll change the layer to, let's change it to T place. That sounds good. T place. Alright. Also, let's try to change the align to center. There we go. That looks a lot better. Yep, okay. So now we know this is the plus pin and this is the minus pin. And I think that's it. Maybe we want to put a piece of text on here so we know who manufactured or who designed this. So let's go put another piece of text down that says basic PCB blinker. Well, let's do basic LED blinker. That looks good. Okay, notice how it's way too big. That's way too big. We need to shrink that a lot. So I'm going to put it down, just drop it, and then press escape, and escape again. I'm going to go to info tool, and I'm going to left click on this, and I'm going to change the size to 0.04 should be good. Let me see if that's okay. Yeah, that should be alright. So let's drop it there again. Press info again, and we're going to change the layer again to, this time we're going to do T names. That sounds good. So we'll go T names, and let's change the alignment to I don't know. You can leave it alone. It's up to you. And then we're gonna go to move tool again. Left click on the piece of text. Scroll in here, zoom in, and I'm gonna press the left or the Alt key on the keyboard so that I have more granularity in where I place everything. If I didn't, then I'd either be like right on the edge of the board or too close to this. So I'm gonna hit Alt and I'm gonna place it right about there. That looks pretty good. Unless you guys see a better place to put it, which might actually be right here. Notice how I just rotated that like that. That actually might be a lot better, because when you manufacture this board professionally through like a company, they'll put a piece of solder mask over the whole board, so you won't be able to see this track so clearly. And you can put text over tracks, that's just fine. You just can't put them over vias and pads and whatnot, because that's where solder goes, I guess. So you can't put silkscreen there. Alright, so let's go ahead and save this. Go File, Save, and that's it. We have a finished PCB now. You could change it all you want. You can change the vias and do double layer, or make it a smaller board. Maybe go to surface mount if you wanted to. Put a ground plane in would be good. Maybe we'll cover that in a coming video also. But for now, this is just basic PCB layout, your first PCB. We'll get into the more complicated stuff later. Alright, so hope you guys enjoyed the video. Make sure you subscribed if you did, or hit the like button down there. Helps a lot. And also make sure you guys tell me what you want to see in the future. If you want to see longer videos or shorter videos. This one's shorter than the previous one, but still longer than my first video. But I'm going to go ahead and cut it off now. Alright, see you later.